Hello everyone, welcome back. This is Anu here. Today we are going to discuss about one of the basic concept regarding the system design that is called the internet. How the internet actually work behind the scene. We are going to see how it is going to happen and what are the important components involved in the internet communication. First of all, what is internet? Internet is not just a cloud. There are billions of devices connected together. Either can be client machines like laptop or desktop computer or mobile devices like and servers, etc. They are all connected together over a specific protocol. This is called the internet. How it is happening? Suppose if you're going to type a URL in your browser and going to and hit enter, how it is going to display that particular web interface in your browser? That we're going to see today. The whole internet is going to work in three layer. As you can see in the screen, the first one is the client network that's within our home network or office network. Then that communication will go to the public internet through the public internet from our ISP, that is Internet Service Provider, to the destination Internet Service Provider. It will pass through many routers and reach the destination ISP. From the destination Internet Service Provider, that communication will go to the data center where our data is residing or where our web browser is residing. Let's go ahead and see few concepts. What are the major components involved in this communication? Okay, first of all, we will see what is this client network, what are the components of client network, and what will happen if we type one URL in our browser. What is the first thing is going to happen? Let's go ahead and see. Okay, suppose this is my browser. I'm going to type one address, and it has to reach the data center and give the response back, and we should get that Google Web UI. Google Web UI. We should get that Google Web UI. How this communication is happening? First of all, when we type the google.com, our browser, okay, our browser, where it will check whether this details available in the browser cache. If previously we have visited this website, the browser will keep that data in the browser cache. First, it will check whether this details are available in the browser cache. If it is not available, then this communication will go to the DNS resolver. DNS resolver. And the DNS resolver also will have the cache. It will check whether these details are available in the cache or not. If it is available, then the details will be given back to the browser. If it is not available, then it is called the cache miss. In that case, it will send the details back to the root server. Okay. But the root server doesn't have the details. What it will give, it will say you have to go and see dot com TLD, top level domain .com TLD. Now the DNS resolver has the details where it has to go and see the top level domain or .com. Now it will go to the .com TLD and it will fetch the details from the .com TLD. Now from the .com TLD, it will get the domain name. Now it is in the, it has to go to this one. What it will be doing, then we have to go to authoritative server. Authoritative name server. Name server. The authoritative name server will have the complete domain details. Domain name mapping means domain address www.google.com to IP address. Now I have the IP address, and this will be given back to the browser. Now using this IP address, we will request the web user. Sorry, using this IP address, now we can request for the resources in the sense. It can be Google's web UI. We can go ahead and ask. Now using this IP address, we can request for the resources to the destination server. That is called the. It is going through the protocol called HTTP protocol. HTTP protocol. Now, using this IP address, we will use the HTTP protocol to communicate with the server. Communicate with the server. This is how this the whole DNS resolution is happening. Okay. Now let's go ahead and see what is happening behind the scene. Once I have the IP address, now this is the client. Client means browser. Okay. This browser is residing in my home network. This is residing in my home network. Now, from the DNS server, I got the IP address. Okay. Using this IP address, now I have to go outside my home network and search for these resources. Now it will be, this communication will be given to my router, internal router or Wi-Fi modem. Okay. And router will have few functionalities. Router will be having one public IP address given by the Internet Service Provider or ISP. It is having only one public IP, and within the house there will be multiple users will be connected to the router. I'll be connecting to one computer, and someone else will be connected to different other devices. Someone else will be connected to mobile phones. Someone else will be connected to desktop machines. Like the different devices will be connected. Each one will have the IP address. To IP1, IP2, IP3, IP4. But our router will have only one IP, one public IP. Then how it will be giving different IP address to different devices? That is through one protocol called DHCP. It's called Dynamic Host Configuration Protocol. And using this Dynamic Host Configuration Protocol, our router will assign dynamic IP to each and every devices. And that dynamic IP through the DHCP IP, we'll be sending packet to this public IP. And this translation is happening through another protocol called Network Address Translation or NAT. Through this NAT, all the communication will be transferred to the outside world to this public IP. This is how this communication is going outside our home network. Now we are outside the home network. Okay, let it be there. Now we are in the outside network. In the outside network, first it will be source internet service provider. Now from the browser, we are hitting the source internet service provider. The source internet service provider, it will go to different core routers. For router 1, then core router 2, etc. Then finally it will be reaching the destination internet service provider. Now we have reached the destination internet service provider. Once it reaches the destination internet service provider, then the communication will be transferred to data center network. Data center network. Okay, this is stage 2. In the data center network, what's happening in the data center network? In the data center network, we have this communication. This data will be given to the load balancer. There are different kind of load balancers are there. We have layer 4 load balancer and layer 7 load balancer. Layer 4, that is L4 load balancer, that is called the network load balancer, and layer 7 load balancer is called the application load balancer. And what the functionality of load balancer, that there are millions of requests will be coming to uh, a website. It will be very difficult to handle all the requests by a single server. There will be multiple servers will be there to handle these many requests. But how this request has to be processed? It will be very difficult if you are manually assigning them. What the load balancer will do, it will equally assign the traffic among all the underlying servers. There are different algorithms are there to do this load balancing, just like round robin. Round robin is the one. Then there are two type of load balancer. One is a network load balancer. Another one is the application load balancer. From the load balancer, the traffic will go to the web server. Okay. In the web server, we will be having different components. Web server will have static pages. Those static pages may include CSS, JavaScript, images, videos, etc. Okay. Apart from that, we'll be having dynamic pages. Okay, dynamic pages or contents. What does dynamic content include? They may include the login details, authentication details, and such kind of secrets are saved in the dynamic content. Those details will be residing in the database. Okay, and the web server will conduct will give the static content as well as the dynamic content from the database. Once the web server has all the details, then it will go to another layer. It is called the content delivery network. Content delivery network, what it will be doing? It will cache the static pages, cache static content. Why it is caching? The next time, whenever we request this data, it would need to go to this web server and fetch all the details. It will get hit from this cache memory. You'll get it from the cache memory immediately. It will give the details. If that cache is not available, then only it need to come back to this web server and fetch all the details. And once it have all the details, it will go back to the system through the same way it came. It will go back to the web browser and it will give all the required details. We call it as DOM, that is document object model kind of thing. Or the web, we will get the web user interface and all. This is how this internet is working behind the scene. This is all messed up. What I have written, this is all messed up. Will not be able to understand what is this. I will go ahead and show you what exactly. Um, I will go ahead and show you what exactly I have written here in a perfect way. Let's go ahead and see what is happening behind the scene. Okay, as I had shown you earlier, that is a client network. That is a private network that is residing within our house. We will be we will be typing the URL details in the browser. Let's go ahead and see what are they. Browser is the client. Okay. The heart of, before going to that one, let me tell you one more thing. The heart of this internet is, we can call it as a client server architecture. Client is our browser, and the server architecture is server, that is the web server hosted in some data center. This is called the client server architecture. We will we will send some requests from the client side to the server side, and we will get the response from the server. And so far, what I had discussed is how this client server communication is happening from your browser. Then it will go to the data DNS system, that is domain name system. First, the IP address from the domain name system, then the URL. Then the browser will send request to the destination server through some protocol. We call it as HTTP. We call it as HTTP protocol, Hypertext Transfer Protocol. Using that protocol, we'll be sending requests to the server, and from the server, we'll get the response back to our web page. This is how this flow is. Yeah, browser is the client where we are where the request is starting, or the software that make the request on your behalf. When you type the URL and hit enter, the browser orchestrate the entire request pipeline. That is DNS lookup. It will go to the DNS server and get the details. And it will do the TCP connection. That is, then it will do the TLS handshake, HTTP request, and finally rendering the response into the visual page that we can see. Okay, so these are the key concepts we can see from here. That is DNS resolution, TCP/IP, TLS configuration. TLS is transport layer security, and we have different levels of transport layer securities are there. That is TLS level 1, 2, 3, like that. Then the browser cache and document object model rendering, DOM rendering. This is what the first stage of client layer, that is the browser. Then what the browser is doing, first it will go to the DNS resolver and get the IP address from the DNS resolver. Suppose if I want to get the IP address of google.com, it will go to the DNS server and fetch the details of google.com. How it is happening behind the scene DNS server? We have different mechanisms happening in the DNS server. First, it will go to the root name server. From the root name server, that communication will go to the TLE, top level domain. From the top level domain, it will go to subdomain and then come to the host name. Like that, the communication is happening. Finally, it will go to the reaches the authoritative name server. From the authoritative name server, we will get the IP address of that particular name, the Google domain name. Okay. Suppose if you are typing www.google.com, there is a trailing period is there, that is called the root. The communication happened from right to the left. First, it will go to the root. That will give the TLD. TLD means top level domain. It will give, you have to go ahead and see .com or .ca or .org. From there, we'll go to the .com domain system, that is the domain. Then from there, we will get the domain name, registered domain name for that particular, that is Google. Register with the register. From there, we'll get the subdomain. Subdomain, whether what is the subdomain means whether it is www or mail or API or CDN, like that. This is how it is happening. There are few DNS records type are there. One is A record that will map the domain name with the IPv4 address. Is if it is a 4A, that is mapping the domain name with the IPv6. Then we have this CNAME, that is aliasing a domain. It's a alias, that is map one domain to another domain. That is MX record, that is a mail server. And TXT record, that is arbitrary text we use for domain verification and all. NS record, that is the name server record or authoritative for this domain. And TTL is the time to leave. These are the major concepts we have understood. There is recursive resolver or root name server. There are 13 root servers are there. I have already discussed those details in detail in the DNS topic lecture that you can go ahead and see. Next come to the TLD server that also I have discussed earlier. Authoritative name server, then DNS cache or time to leave, and DNS or HTTP. Next come to the home router. Home router, that is the gateway between our internal network and outside world. Okay, there is nothing to discuss about that. Only few protocol. DHCP server, the home router will have the DHCP server. Those DHCP servers are giving multiple dynamic IP address to different devices within our houses, and after that those communication will be transferred through the public API using network address translation or NAT protocol. Then the communication will go to the public, that is the internet. We have the local ISP, that is our internet service provider who is giving internet service to our home network. Then it will go through different core routers. Then finally it will reach the destination internet service provider. Once it reaches the internet destination internet service provider, those communication will be transferred to the data center where our service is hosted. There are different load balancers are there. I have already said that we are going to discuss in detail what are the kind of algorithms available for load balancer. One is round robin. Okay, request go to each server. Intent, that is one. It will go to first request will go to the first server. Second will go to the second server. Third will go to the third server. Again, this cycle will happen 1, 2, 3. Okay, next one is the least connection. The request will go to the server with least connection. That is called the least connection algorithm. IP hash. Some client IP always route to the same server, useful for session stickiness and all. Then weighted, more powerful servers get higher proportion of the request. That is, I have set up one server today. After 5 years, I'll be setting up a powerful server. At that time, that server will have the capability to handle more requests. Then at that time, the more requests will go to the system will have which is having more powerful resources. Next one is health base service that will fail health check are automatically removed from the rotation. This is what this different kind of load balancing algorithms. Okay, these are the tools which use for load balancing job, that is Nginx, HA proxy, AWS or AWS load balancer, GCP cloud load balancing, Cloudflare, and Airfix. These are the few load balancers available globally. Next, come to the web server. A web server will serve the static and dynamic content. Dynamic content will be fetched from the backend databases, and once it's fetched all the details, it will go through the content delivery network for caching, and then the details will be given back to the client network. Let's go ahead and see how the animation or something. This is the flow happening from browser to the DNS server, get the IP address to the home router. To the next stage, it is to the public, that is from our ISP to the core router, different core router, then destination ISP. It will go to CDN. It will check whether the cache details are available or not. If it is not available, it will go to the load balancer, web server, and database. Get the request back and it will go to the CDN network and it will give the details back to the client network. Here's a simple schematic animated diagram from the browser. It will go to the DNS server, get the IP, go to the home router. Next thing is we are in the public IP, public internet. From our ISP, it will go through different core routers. Then it will reach the destination internet service provider. Once it reaches a data center, it will go to the load balancer. First, it will check whether it is available in the CDN or not. The load balancer will try fetch the details from the CDN if it is available. Otherwise, it will go to the web server data center, and once it fetches all the details, it will go through the CDN network and give the request back to the browser. This is how the flow is. Now let's go ahead and see few commands to understand this internet and how the internet is working and how these hop counts are going, or how the communication going through different root servers and all. Let's go ahead and see. Let's open the command prompt. First thing is, if you want to see the IP address of google.com, we can use nslookup. nslookup google.com. If we execute this command, this is my home network IP address, is private IP address, and it is giving non-authoritative answer. Name is google.com. These are the IPv6 address. These are the IPv4 address for google.com. Next one is if you want to see the IP address of your machine, it's called ipconfig. If it is Linux, then it will be ifconfig instead of ipconfig. It will give your IPv4 address. It is private IP starting 192.168. That's a private IP address. And next, come to see if you want. If you want to see your public IP address, you can execute this command curl if config.me. I don't want to show this because it is going to expose my public IP. I don't want to do that. Then private IP, that is ipconfig, you can execute. Then come to trace at google.com. Let's see. It will give all the details from our local home network. Then it will go to the ISP. From the ISP, it will go to the first router, core route, then to the core route 2, and it will finally reach the destination. This is how it is going. It will give all the details of that particular movement of package from source to destination. It will take some time. Let's cancel that. That's concept behind this trace route. The next command is ping. Ping means it's a round trip from here to Google to come back. How much time it is taking? That is time to leave and all. It will be reply from Google. I got it took around 32 bytes. Time taken is 14 millisecond. Detail is 111 second. I think second. This is the round trip taken to communicate with the Google server. These are the few details about this internet. These are the key takeaways we have learned in this session. One is what is meant by DNS. Another one is IP address itself. We have two: public IP address and private IP address. Client server architecture. What is meant by HTTP, routing, and TCP. This is all about this how this internet actually work behind the scene, and hope you enjoyed this video. Thanks for watching this video. Have a good day. Bye.